Hello, welcome to my next video on architecture and design. Today we are going to learn about UML sequence diagram. I will be providing sample sequence diagram that will helpful to you to practice yourself and have hands-on experience on driving sequence diagram. Usually we will get the requirements from the customer or stakeholder in the form of Excel spreadsheet or Jira or in the form of user stories. Sometimes we will get requirements in the form of use case diagram. From the use case diagram, the next step as part of architecture and design is to draw sequence diagrams. If you see here, and we have a use case diagram stated here. There are 5 use cases defined here. After understanding this use case diagram, the next step as part of the architecture and design is to draw the sequence diagram, whatever stated here. If you look here, this is a sample sequence diagram. This sequence diagram is common across any programming language. It follows unified modeling language notation. If you look here, this is an equivalent of one of a use case, and that is depicted in the sequence diagram. We will see what is the use of every symbol, like the human like symbol and a top rectangular box, and you have vertical box, and you have arrows connecting between the vertical box, and you have a self loop kind of symbol, and these things that we will learn it in the succeeding slides. Well, what is a sequence diagram? It is a UML notation which uses use case or Excel spreadsheet or your Jira use case diagram or user stories as an input. It is one of an important phase in software design as well for system modeling. Irrespective of the programming language, you can visually represent a sequence diagram that can be easily understood by the stakeholders of an application development. You can use UML diagram as a system integration diagram. It will tell you all the internals of a sequence of flow of event that will helpful to you to build a large integration diagram for your application. Next comes a sequence diagram represent a use case or a user story that will clarify the execution of the different event or sequence of event within the user story. It will tell you the exact order in which the events or the messages are all passed between various components. In short, UML sequence diagram is very useful for designing real-time systems. It is used for depicting an API or microservices. Soon after building and hosting an application it into an environment, if there are any issues or any changes required in the system or in the API, these sequence diagrams will be helpful for an IT developer to troubleshoot and debug the application by understanding the message flow between various components. So it is not only used for just a documentation purpose. It's a powerful tool at the initial stage of the design. It helpful to analyze what is going on in a particular feature or a user story, and it will definitely help to improve the overall system performance analysis and improve the understanding of the system. And you can use this UML sequence diagram to collaborate effectively with the stakeholders of the application to ensure correctness and improve the quality of the code and the design. So these are the advantages of having a sequence diagram as part of your normal software development life cycle. Well, if you see here, these are the different notations used in the sequence diagram. If you see here, the key important stuff is you have three different ways by which you can define a lifeline. You can have a rectangle box where the component or object is specified, and it has a dotted or dashed line. That's nothing but a lifeline. Instead of this object, you can have an actor that have a human symbol similar to your use case diagram that can also be called as a lifeline, or simply a user with a dashed line that can also be considered as a lifeline. Over the lifeline, you can draw a rectangle box like the one whatever you are seeing here. That's called activation. So if you have, let's assume that you have two rectangle box here, you can establish a connectivity between these two. Thereby, you can have association between these two lifeline, and that's where we are having the activation. The lines which represent between two lifeline, and that's called a message. There are different types of messages are there. One is called synchronous message that has a flat arrow, which is whatever you are seeing it here, and you can have, yeah, like you can have an arrow message with a pointed one that's used for asynchronous message. The same asynchronous message can also be denoted in this format, a line with a slash. So these are the forward arrows. You can have a written message from here, one of the activation to another activation. Usually, this is denoted in a dotted arrow. That's called a written message. And in an activation, you can have an arrow pointing to itself, similar to whatever you are seeing here. And it can be rectangular or curved one. That's called a self message. So in this message, you can have a label that will tell you about what is the action performed between the activation. Say for example here, create an object, create a message, delete an object or destroy a message. And if you look here, we have a pointed arrow which is in the asynchronous format, and we have a cross in front of that. This is another one that is meant for delete or unload operation. And you can have a state divider between sequence of events that is denoted by dashed arrows. You need not have an arrow like a synchronous message or asynchronous message or written message. If your sequence diagram is complex, you can divide it into multiple number of subsections. That's called state divider. Well, sequence of events can be grouped together, and that can be denoted in a common box, something like this. And the first form is called as loop fragment. Here you can mention about the condition and the parameter associated, and you can have sequence of events specified under this particular box. You can also mention optional fragment like this. same notation. You can have a complex fragment where you have a condition and the true part will go here and the else part can go here. And if you look here, we have a dashed line that is nothing but the state divider. So this is the way that you can make the sequence diagram modular. The other format is you can have a very simple plain parameter similar to this loop format. You can have your logic built inside that. So these are the ways by which you can, these are the notations that are going to be used in our sequence diagram. Now let's see how to use this symbol with proper examples. Well, I'm going to do a deep dive into the symbols. I mentioned, if you look here, these are nothing but actors in the use case diagram. Same thing can be used in the sequence diagram also. So these can be specified as object in a rectangular box. And every object or component that are all specified at the top like this, it may be a object, or it may be a component, or it may be a layer, or it can be a device, or it can be a service. And each component or actor will have a dashed arrow like this, and that's called lifeline. So lifelines are all nothing but the dashed arrow connecting actor or object or a service or a device or a layer. So they are used to denote how actors are all connected, and the dashed vertical lines representing the existence of an object over a time period. Now these activation bars, which are all vertical rectangles drawn over the object lifeline, that will indicate this is a start of the activation and this is the end. If you look here, I have two objects. One is the actor and the object that have a start of activation bar and the end of an activation bar. And here I have another object, which means a web user, which has start and the end. We have an authentication service that can also have an activation bar. We have a file that has an activation bar. Now, an activation bar in a lifeline can have multiple number of the activation bar, similar to this whatever you are seeing here. Okay, it can be n number. It can be even a small stuff. And this is used to connect the objects and the lifeline. We will see it in the next slide. If you look here, we have an object 1 and object 2. And we have an activation bar which starts here. And this is connected to another object, and this is in a proper arrow. That's nothing but the message, a sequence. So this arrow indicates a communication from one actor to another actor. It usually starts at the top and end it here. If you look here, between these two lifelines, you can have an arrow connecting to these two lifelines, which starts from here and end here. But you cannot have a lifeline which crosses this and connect to somewhere here. This is not allowed. Okay. So the lifelines or the messages are drawn from one sender to another receiver. You can have these messages can have text over it, something like whatever you are seeing as hello. You are having a message shown here, and the messages can be numbered with a text, or it can be just some number 1 2 thumbs or a b c d, something like that. And uh, uh, you can refer this number and textually explain it as part of your design documentation. So this is optional. You need not have the text over message or the numbering over message for all the messages between the lifeline. That's an optional one. Now, the messages can be of two different types. One is sequential and the other one is asynchronous messages. Sequential synchronous message are the one which starts from a lifeline and end it in the next one. So here in this message, it waits for reply before the interaction can move forward it into the next message. See, this is a start, this is the end, and the sender object will wait for response from the receiver. So the synchronous messages are all denoted by a solid arrowhead like whatever you are seeing it here. Contrary to this, asynchronous messages are all denoted using open arrowhead between two object or lifeline. So the another main difference between synchronous message and asynchronous, the receiver has to wait, the receiver must send back the response to the initiator or sender, who can proceed the next action. Say for example, in a traditional programming language, all function calls in a program are all considered a synchronous message. Same thing here in the asynchronous message. The best example is you can have batch processing, whereupon the receiver can process the message at any time. It can be immediate or it can be scheduled for a particular day or time, and the sender need not wait for the receiver. That's the difference between synchronous and asynchronous messages. Now, as an example, if you see here, the first diagram is meant for synchronous messages, synchronous communication between two objects. And we have a monolithic application and we have a database. And we have actors specified here. So this is a use case login. They log in it into monolithic application and it calls a method, connect to database, verify the credential, and send back a message that's called success to the object. Look out here, this is the start, this is the end, and here this is the start, this is the end. So synchronous messages have to wait for the response from the receiver in order to initiate the next message. If you look here, the objects can also be specified twice or only once at the top. So both options are allowed in sequence diagram. And look out here, these arrowheads are all solid head, and that means that it is a synchronous message. The same thing here. Look here, the human symbols are all denoted in a rectangular box. That is also allowed with a lifeline having the same functionality replicated here. It's a login, verify credential, and a return message. If you look here, the return message is not a solid head. It's a pointed head. And since it's a return message, it is specified in a dashed arrow. And so this is an example for asynchronous message denotation in sequence diagram. And this is how you can draw sequence diagram for a very simple use case, whatever you are seeing here. The labels, the numbering are all optional. If you provide this information, it is very formal and easy to understand for anyone who review the sequence diagram. Well, let's see about the return messages. We have already seen the return messages are all of the type of dotted messages. It can have a open arrowhead or a solid arrowhead. The difference is synchronous versus asynchronous. The return messages, usually it is good to have return messages, but it is optional in sequence diagram. Return messages can be either a method or a function or a data or a state that can be referred over the dashed arrows. Next one, let's see more example here. This is another example where we are calling a function. And if you look here, we have the return messages which are all specified in a different format. Look here, in this diagram C, we don't have any return messages noted here. However, this particular scenario, in the first use case, sending mail to notification service, does not require any return message back to the sender. And so we are not specifying any return message. And we are proceeding with the next one in an asynchronous way. That is, proceed with the next task. That's a function. It's also not waiting for any response. We are moving to the next one, deliver email. And so, return messages are optional. Now let's see one more example. Messages with broken lifeline and message numbering. If you look here, we have an object specified at top and a lifeline, and this is a shorter lifeline and this is a longer lifeline. And if you see, this is the first event and down below this is the second one. So this is a broken lifeline. This is called a broken lifeline. If you have an arrow which points from here and then connect to this lifeline, here it is a continuation, whereas it is a broken lifeline. It can be a delay or it may be a representation to understand the sequence of event one after another. You can take in both the ways. Look here, another message where we have numbering. So the arrows between the lifeline which indicate whether it is synchronous or asynchronous or a return message, and also provide sequence of event. Other than that, there is another message called self message. Self message usually in the sequence diagram meant to represent message pointing to the same object or same lifeline again. It's a kind of loop. It can be a callback function, whatever you are seeing it here. It can be used for a recursive function. It may be a recursive call to the same method. So it's a message. If you see here, it can point to the same lifeline. Sometimes we can use a double rectangle as shown here to represent a recursive operation. This is another best visual representation to represent SQL representation or self messages in a sequence diagram. If you look in another example, we have an object and we have lifeline. It is open camera, open nodes are the two sequential operation that's happening inside an application called MS Teams. So this is how you can represent self messages. The next one is about the gods. The next one is about the gods. Gods are a kind of a special notation in the sequence diagram which specified the conditional information above the messages. What it will do is you can mention the conditional statement over the message that will provide information to the sequence diagram user, and they will decide about how the messages are all flowing in. It plays an important role in letting the software developers to know about the conditions attached to the system or a particular process. Let's take a scenario. If you see here, we have an object, that is a client places an order. We have another object, that is order service. So the arrow connecting the client and order service can have a message that's nothing but a god or set of gods that would validate the condition before this order service is serviced. So what are the gods associated with this message? If you see here, there are three gods. One is an authentication god that is responsible for checking whether the user is logged in. Next god is talking about whether the item ordered have enough stocks in place to check against the inventory. Next one, whether the payment details are all valid. So these are the three gods are all checked before order service is serviced. So this order service will be called only if all the three, whatever mentioned here, are all processed, so that the order service will be executed and the data will be saved into the database. That's another object. Let's see an example of this flow. If you look here, we have a client, there's an object, and these are the gods. These need to be passed in order to make a final call to order service, which in turn plays a successful insert operation or save operation into the database. So these three gods are all mentioned here. Check for the stock, that's on the inventory, and the first one is check for whether it is properly authenticated or not, and then it checks for valid payment or not. If all the three passes, it proceeds with the order processing and the order will be saved it into the database. In case if any one of them fails, the order service will not be called and subsequent return messages are noted down here for payment declining a payment or product not available in inventory or authentication is failed. This is how gods are all handled in sequence diagram. Without these detailed gods, the sequence diagram looks like a plain vanilla one, means the three detailed gods. Instead, you will have a pre-check and that's only going to be called. Now, let's see the new user registration for online shopping website. We have an object that's user and we have a registration page, a validation service, a user service and the database. So when the user fills in the data in the registration page, validate the data will be called. In the validation service, there are multiple things are all performed. One is for processing the data entered. If it is valid, what will happen? And the other one, if there is an invalid data, what is called? So these two are all separated by alt. So this is for positive cycle and this is for invalid or negative cycle. So once the valid data is entered, a new user account will be created using a new method which in turn calls save user data, saves the data into database and this will be confirmed back and the message is passed back into the user. If there is a failure, error message will be returned back to the user. So this is on the new user registration for online shopping website. Now let's see the login sequence, that is post registration. The same user enters the credential in the login page. We have an authentication service, that's another object which authenticate it and validate the data against the database. And so if you look here, we have start and end, and we have start and we have end here. If you want to specify, you can handle, you can have a rectangular notation here to specify that this is what the slim line where the activity enters and the activity exits all can be specified here. And if you see here, send the login request to authentication service, which will fetch the data from the database for validating the credential and it will return the result. It can be a valid or it can be invalid. If it is valid, success message will be returned back. If it is invalid, error message will be returned back. Look at here, we are specifying the same object at the bottom also. As I mentioned already, you can mention the object both at an up as well as the down portion of a large sequence diagram to make sure that the person who is reviewing or using the sequence diagram can easily understand what are the different objects, services, entities, elements, or systems involved, and what are the messages between messages used between the objects to communicate the data, to collect the data, or through an error message, something like that. Now, let's see a complex sequence diagram. This is a perfect example for event-driven architecture. Let's assume a web user who clicks a particular page or make an order or click a like icon. These are the events. These events are all produced by various user actions and these actions are all captured in separate topics under Kafka. The click topic will hold the click information, order topic will hold the order information, and the likes topic will have the like information along with other information like user ID, order amount, when the user liked it, something like that. And we have a stream process or business logic process that subscribe to these three topics and pick up the associated topic, process it, and then update back either the same topic or update it into the new topic. Once the topics are all updated, the event consumer who subscribed to appropriate Kafka topic pick up relevant information from there and then process the message. Post processing the message, the data will be stored either in the database or it can be subsequently called on another service, or it may be a trigger to another consuming application. This is how you can build sequence diagrams. And if you see here, another complex user scenario, sequence diagram scenario. This talks about the same user using web browser make a request to add a new item into the shopping cart. It checks the inventory. If the product is available, the user can check it out and then make a payment. All this information will be stored in the database. In case of failure, either in the inventory level or at the payment service level, appropriate error messages will be retrieved and then sent back as an error notation to the user. So let's take an inventory scenario. There are two different scenarios. If the product is available, you can make a successful processing of the payment. If payment is confirmed, update the order status and then say that payment is successful. In case if the inventory is not available, you are going to say that stock level is not good enough to proceed with the payment. Update the stock level and send back the stock details to the user. And so these are the different conditions that you can use alt for sequence diagram. Alternatively, you can have another one to check for inventory unavailable status. So that can check for the status of the product which is being ordered. If it is not available, it will throw a message stating that the stock is not available and try again, something like that. So this is how you can make use of alt in a complex sequence diagram scenario. And with that, I end the sequence diagram session. I hope this session is helpful to you. Please go through this video soon after completing the training on use case training video, which is published a couple of months back. I hope this message is helpful to you. Good luck.